Around the turn of the 20th century, a researcher at the German Physical Society set out to push the boundaries of science. The theories concerning light contradicted an experiment carried out in many laboratories at that time. Like many other researchers at that time, Max Planck had been mulling over an experiment by Gustav Robert Kirchhoff, who was working with apparatus to produce heat from light. Like Kirchhoff, Planck too possessed a thermal radiator, an electrically operated source of electromagnetic radiation. It was rare at the time to work with such equipment, especially as electricity had only been introduced to Berlin a few years earlier. Planck, a theoretician, preferred developing formulae to conducting experiments. But none of the long-established formulae helped him describe what was going on with this cavity radiator. Planck began to work on a new law of radiation to calculate the energy emerging from the radiator. The day came to put his theory to the test. A spindle wound with wire is placed inside a completely black tube. Electrical current is passed through the wire, heating the assembly to a constant temperature. From the mouth of the black tube, electromagnetic radiation is emitted in the form of light, in all colors of the rainbow, meaning light of different wavelengths, even ultraviolet. However, the formulae of the time said that to produce such a spectrum of light, an infinite amount of energy is needed, and that is clearly not possible here. Researchers even went so far as to name this phenomenon the ultraviolet catastrophe. With some hesitation, Planck conscientiously began to refute the established laws of physics. He postulated a new constant, little knowing that it was a physical constant in nature, now known as Planck's constant. It describes the relationship between the energy of a photon and its frequency. Planck named the value h, as in help, in the hope of returning to and bettering the formula in the future. In 1905, a Zurich physicist, Albert Einstein, corroborated Planck's findings. Light doesn't release its energy continuously, but rather in small packets, or quanta, as the energy units of photons are referred to today. Planck's experiment marked the birth of quantum mechanics. In 1918, Planck won the Nobel Prize for Physics, as did Einstein in 1921. The mystery of light was decoded, and all of this happened just 100 years ago. Today, flicking a light switch is taken for granted, and the results still obey those theories and rules first described by Albert Einstein and Max Planck.